Hi there, I hope all of you guys and your families are doing well. So today we're going to be starting the gases and the atmosphere unit. Okay, so the first part of the gases and atmosphere unit is pages 1 to 13. So all of the material in the booklet between pages 1 and 13, it's up to y'all to sort of have a read through all of those notes, answer the personal response questions, and then fill in the pages there about the names of the scientists and what their contributions were. Okay, so it's pretty much a reading assignment. You just read through all of those notes and fill in the information there and respond to the questions. So in general for this unit, what we're going to be doing is talking about gases. So many of the different formulas that we can apply to gases and stuff like that. But before we do that, we're going to start talking about the atmosphere in general. So, like I said, the majority of this stuff is up for y'all. It's up to y'all to sort of have a read over and appreciate, and then just let me or Mr. C know if you have any questions. But there are a few things that I am going to sort of talk about in this short video. The first thing is the temperature of the Earth throughout time. Okay, and the second is going to be the oxygenation of the Earth. Okay, so when you read through all the notes in your booklet, you're going to see that the surface of the Earth's temperature has changed dramatically throughout history. So we've had ice ages where the surface of the Earth has been very cold, and then we've had other periods where the surface of the surface of the Earth's temperature has been a lot more mild and has been quite warm. And the biggest thing that influences the temperature of the Earth is the concentration of carbon dioxide in the atmosphere. Okay, so we say the temperature of Earth is determined by the concentration of carbon dioxide in the atmosphere. Okay, so if the Earth had more CO2 at one point, the temp is higher. Okay, and if the Earth had less carbon dioxide in the atmosphere at a certain point in time, the temperature was lower. And the reason for this is because CO2 is what we call a greenhouse gas. Okay? And CO2 is a greenhouse gas because it absorbs infrared radiation and reflects it back down onto the Earth. So if we draw the surface of the Earth here like this, okay, so let's say this is the surface of the Earth, or the Earth's crust. Okay, and let's just say this is the atmosphere. Okay, we have the sun here in outer space, and the sun is going to shine upon the Earth. Okay, and put a lot of infrared radiation and visible light onto the Earth's surface. And what ends up happening is a lot of this radiation from the sun is reflected from the Earth's surfaces back into the atmosphere. Okay, then the CO2 in the Earth's atmosphere is going to absorb that infrared radiation and reflect it back onto the Earth. So this is like a greenhouse. Heat energy is coming in and not being allowed to escape because it's being trapped by the carbon dioxide. So in periods of time where we had loads and loads of carbon dioxide, we had a lot of heat from the sun being trapped in our atmosphere. And in times where we had less carbon dioxide, a lot more of the infrared radiation was able to sort of escape back out into space. So that sort of explains why the concentration of carbon dioxide affects surface temperature of the Earth. It also explains why scientists are concerned with fossil fuels and stuff like that, because whenever we burn fossil fuels like natural gas or whatever, it's going to release carbon dioxide, and when we have carbon dioxide in the atmosphere, again, it's going to absorb the infrared radiation being reflected from the surface of the Earth and then reflected back down onto the surface of Earth. It'll prevent it from being cast back out into space pretty much. Okay, so that's why CO2 influences the temperature of the surface of the Earth. The other thing I want to talk about quickly is the oxygenation of the Earth's atmosphere. So if you read the notes, you'll learn that at first the Earth's atmosphere hardly had any oxygen at all. And during those periods of time, we wouldn't have been able to have any aerobic life forms on Earth. So, most life forms on Earth require oxygen to live. Certainly things like mammals, even fish need oxygen. Most living things that we're aware of need oxygen to survive. So, at certain points in the Earth's history, the atmosphere didn't have much oxygen at all. So, at that point of time, most of the animals we are aware of wouldn't have existed. The plants either. But what ended up happening at some point is some types of bacteria, known as cyanobacteria, evolved. And these cyanobacteria are photosynthetic life forms. And what that means is that they would create energy from the sun, and in doing so release oxygen into the air. And once the level of oxygen in our atmosphere rose to a particular point, aerobic life forms were able to evolve. And that's sort of how life came about as we know. So if we look at the equation for photosynthesis, so again it was these photosynthetic organisms known as cyanobacteria that led to the oxygenation of the atmosphere, and they led to oxygen being released because they were doing photosynthesis. So remember, with photosynthesis we have carbon dioxide and water coming together to create glucose and oxygen. So that's C6H12O6. That's oxygen. I haven't balanced this, but if you want to balance it, you can go straight ahead. So we can see here, it's because these life forms produced O2 that the Earth's atmosphere became oxygenated. So that's pretty much it. I just wanted to sort of explain those two things to you a little bit. So you just have to go ahead and read all of those notes between pages 1 and 13 and fill in your answer to those personal response questions. And then the part there about the scientists and what their contributions were. Okay, have a good one.